The title of this video may look like clickbait, but it's definitely not. I'm going to show you two images, and I want you to decide which image is animated to move and which one is a still image. Okay, here's the first one, and here's the second one. If you guess that image 1 is the one that's animated to move, you would be totally wrong because they're both still images and they're hacking your perception. In this video, we're going to talk about how. Hello Neuronauts, Cognic here, and today we're going to talk about still images that appear to move when you look at them. We're going to look at some of these images while we talk about the reason that they might actually trick our brains. At the end of this video, I'm going to create one of these images myself to show you guys just how easy it is to make these mind-bending pictures on your own. Before we get started, I also wanted to say thank you because we passed 250 subscribers, which may not seem like a lot, but it means a lot to me. We're well on our way to 300 subscribers, so if you're new to the channel, feel free to like this video if you enjoy it and subscribe to the channel. Thank you all for the incredible support. Okay, I'm gonna put the thumbnail of this video up on the screen right now. If you see it moving, then it's actually tricking your brain because there's no movement going on at all. To talk about why images like this move, we have to first talk about perception. Perception is how we experience the world around us through our senses. Consider this mug. You can see the image of this mug because light is bouncing off of the mug and into the camera sensor. As much as I try, I can't put this mug into the camera. That just wouldn't make sense. The camera doesn't have access to the mug itself. It only has access to the light that's bouncing off the mug and into the sensor. In perception research, we would call this mug the distal stimulus. It exists out in the environment, but we don't have access to it. We can't take this mug and put it into our eyeball to detect it or put it into the camera. What we can access is the image of the mug, or in other words, the light that bounces off the mug and into our eyes or into the camera. Because we can see this image and we have access to that image, it's called the proximal stimulus. So, to summarize, the mug, which exists in the environment, we have no access to. That is the distal stimulus. But the light that bounces off the mug and into our eye, that's the proximal stimulus. Here's another example. I'm carrying something right now outside of where the camera can see. You can't see it, but it still exists. It's in my hands, so I can tell you it exists. What is it that I'm carrying? Well, the thing that I'm carrying is the distal stimulus. You don't have access to it. All you can do is use your senses to detect what it might be. So, let me give you some proximal stimulus or some data that you can actually take into your brain. Now, you probably understand that what I'm carrying is an instrument, probably a guitar. See, the guitar in this case is the distal stimulus. It exists in the environment, but you didn't really have access to it. But when you heard that sound come out of the guitar, the sound is the proximal stimulus that you have access to. Now you can use that information to detect what the distal stimulus is. I'm sorry if that got a little heavy. I tried to explain it as best as I can. Distal and proximal stimulus can be kind of tricky concepts, so if you have any questions, ask them down below in the comments and I will try to answer them. So why is this important for the still images that appear to move? Well, that still image in the environment is the distal stimulus. It's not moving, but it exists out in the environment. We don't have access to it. The light that bounces off of the still image that appears to move is the proximal stimulus because it bounces off of the image and into our eyes. We have access to that light that bounces back into our eyes. But for some reason, when our brain senses that light coming back to our eyes, it says, well, that thing you're looking at is moving, and it makes you perceive that motion. To be completely honest, scientists don't have an 100% certain answer as to why these images appear to move, but they're pretty sure it has to do with something called the consolidation problem. So what is the consolidation problem? Well, humans on average have two eyes. Some people have one, or some people have three, I'm sure, but most people have two. Because most people have two eyes, we get two different images of the world, one from the left and one from the right. When you look around the room right now, you're probably only going to see one image of everything, not two. This is because your brain takes those two separate images and combines them into one seamless image. That process is called consolidation. The consolidation problem is that neuroscientists don't really know how that combination takes place. We don't know how image 1 and image 2 get combined to form one image of the world. Now, you can actually experience seeing two images of the world at once. I don't recommend doing this because it involves crossing your eyes, which is bad for you. But if you do cross your eyes for just a minute, you'll see two images of the world at once. This is because your brain can't consolidate images that are that different. When you cross your eyes and you point them in different directions, your brain tries to combine them, but doesn't do a perfect job of it, and so you can briefly see those two images while you cross your eyes. Most people don't permanently have their eyes crossed, and so because that's the case, your brain does an okay job of taking image 1 and image 2 and combining them together. So back to the still images that appear to move. Why does this happen? Scientists think it might have to do with consolidation. You see, when you look at one of these still images, your left eye and your right eye each get a version of the image. And when your brain tries to combine them together, it can't. Because these images tend to have colors with high contrast in weird curves and angles mixed together, your brain might have trouble combining eye 1 and eye 2, which would cause you to potentially perceive motion where there isn't any. This is called illusory motion, or motion that isn't really there but your brain perceives, and so it almost creates. The pictures are still, they're not moving, but because your brain thinks they're moving, it shows you movement. It slightly moves things around. Super cool and super trippy. Okay, so now let's try to create one of those images from scratch. I chose to model my motion image after the one from the thumbnail that looks like coffee beans. I started in the free software GIMP, which is sort of like Photoshop but completely free. I made a 64 by 64 pixel square and then added a circle to the middle. I painted half the circle black and the other half white. Then I painted the center of the circle green. This left a white outline on one side and a black outline on the other. I then sheared the circle into a kind of bean shape. Finally, I added some little lines to the middle to add some distracting detail. The reason for this distracting detail is to make the brain work really hard. All of these contrasting colors, lines, and angles will probably make the brain have a tricky time when combining the left eye image and the right eye image into one. If we trick the brain enough and make it work hard enough that it messes up, it might see motion where there is none. I could have painstakingly copy and pasted and rotated this little bean onto an image 510 times, but I have other stuff to do this decade, so I used programming tricks instead. I wrote a small Python script that took the little bean image and then made a bunch of rotated variants of it. The script then takes the rotated images and pastes them into a larger image. The rotation has a pattern to it which I hoped would look a little bit trippy. I also added some code at the end which allows me to change the background color to whatever I please. And so for this image, I chose purple to contrast the light green. After fixing a small bug, I ran the code and I got this. This is the final image. You can definitely see it moving a bit, and while it's not the best motion illusion I've ever seen, I don't think it's half bad. Well, there you have it. Now you know how these images potentially work and how you can create them at home by yourself. Thank you all so much for watching, and I hope you enjoyed the little programming project at the very end. If you're still watching right now and you're not subscribed, please consider hitting the button below and joining the channel. I'm going to be posting new videos really soon, and I hope you'll be around to see them. Take care of your brains, and I'll see you guys in the next one. Peace, guys.